I know many of you think generative AI is just chatting tools. We ask a question, it will give a best answer for us, just like a smarter coworker or chatbot. But what if I told you that generative AI is a pipeline that we can design, build, and govern just like our traditional data pipeline? In this particular video, I'll show you how to build end-to-end GenAI pipeline for internal use. Before we jump into that pipeline creation, I have split this work in three different sessions. The first, what I'm going to cover is I'm going to cover all terms and terminology before we build the pipeline. So again, start with the fundamental, going over the terms and terminology. What is actually a RAG pipeline? What is embedding? What is vector? What is chunking? Why those are important? What is temperature that helps to generate the word and things like that. There are many new terms and terminology we need to understand or digest before we actually build the pipeline. So that part we'll cover as a first section. Probably maybe 20-25 minutes. I will try to explain best of my ability. And we cover that understanding fundamental part. The second part, what I'm going to do is I am gonna show you guys one quick short demo video to create the traditional data pipeline. So I'm gonna show you traditional data pipeline, not writing with the code, but with the help of Databricks AI with no code at all. I will be building the pipeline using AI Databricks with no code. I'm going to show you how it is possible. So that is my second work. And then finally, I'm gonna walk you through all the steps we need to perform to create a generative AI pipeline. And then that's going to be on Databricks as well. I will be, at first we will be doing all the fundamental terms and terminology, discussing those things. And based on those terms and terminology, we will be building that pipeline at the end of the video. So now basically, if you follow along with me or follow all from the beginning to end, you will get the high level knowledge about generative AI pipeline, how it can be built, how we can build for our internal purpose. So that is the main reason for this video. With that being said, let's start with the phase one of generative AI learning journey. So in phase one, we will be covering the fundamental of GenAI terms and condition terms as a build of foundation. So in this particular step, we'll be covering what is generative AI, what is LLM, what is token, what is prompt engineering, what is embedding, what is input in, what is vector search, what is RAG, and what is the role of Databricks for generative AI for pipeline creation. This is all we are covering in high level or theoretical to make basic understanding of these topics before we start creating the pipeline. For these all different topics, in order to understand a little bit clear way, I have split these topics in three different segments. The first segment I make name is a basic. So in basic, we'll be talking about talking with the generative AI. In basic section, we will be covering what is generative AI, what is LLM, and also we'll be talking what is agentic AI as a part of base understanding. We already know all of these, but I'm gonna toss base if something I can cover as a missing part, right? For those, the next step I will be covering on these topics, like what is token. Basically, in the second section, how it works of generative AI. On the how it works section, I'll be talking about the tokens. I'll be talking about the prompt. I'll be talking about the prompt engineering quickly, and I'll be talking about context engineering, how these are important as a part of how GenAI works. And on third part, we will be talking about the limitation of GenAI. So GenAI works perfectly, but it has some limitation. So what are the limitation? What is context window? What is the limitation of that and that? What is hallucination? Why this is how this is coming? What is that basically? What is temperature and things like that? That is limitation part of GenAI learning. And another part will be covering RAG, the critical part. So on that RAG section, we will be talking about chunking, we will be talking about embedding, we will be talking about vector search, we will be talking about the RAG itself, we will be talking about the agentic RAG. So these all may be the new words for most of us, but I will try to explain as basic as I can, right? So chunking, embedding, vector search, RAG, and agentic RAG. And at the end of this terms section, we'll be covering Databricks role, how Databricks can help to build a GenAI pipeline. Right. So these are the 5 sections I have split on those topics. So let's start with the first basic thing. As you know, generative AI basically create the new content, like content, like text, image, or any code, or any question we ask, it is going to return. But how really this architecturally, how where those generative AI sits? So this is where the generative AI is. But there is a artificial intelligence. AI is all on the top, and machine learning will come after AI. Basically, machine learning is subset of AI, and there is come with a deep learning. Deep learning is subset of machine learning, and then generative AI will come the next. So generative AI is next phase of deep learning. So basically, these all things, machine learning, deep learning, and generative AI all work together. And when you talk about the module or large language model is these are a combination of this machine learning, deep learning, and generative. Next is LLM. What is LLM? LLM is a large language model. Is the engine behind the scene. Um, every company has its own module. Like Facebook has on, OpenAI has on, Cloudera has on, Google has on, machine learning, large language model. What LLM does is basically predict the next word, predict the pattern based on the pattern. So when you say the pattern is a machine readable pattern, is based on the machine learning and deep learning. With the help of machine learning and deep learning, it will generate the pattern, next word based on that. Like if you type like the capital of France, it will predict the next word is a Paris, right? So let me quickly show you what I mean in real time. Although there is one, website we can visualize. That's a website called the Transformer Exploration, or what is that? Transformer Planner, right? So right here, we can play around how actually this LLM works, how it predicts. So at the beginning, if you see this in left hand side, there is a human readable data right here. So let me write that word actually. The capital of France is, right, and then I'm gonna write these, and then I'm gonna ask to generate the next word. So let me see what is gonna generate. So as soon as I write this, the capital of France, it generated the for word. So how it generated? So first at the beginning, there is the embedding section. The LLM does not read human language. The capital of France is human language. It doesn't read. So what it does is gonna convert this text to the IDs, and then it has created the position. Basically is tokenize it, so the machine can read it, right? So this is what the embedding phase is. The first is it did the embedding. The second, the capital of France, it has done all this transformation, and then it start doing this prediction. In the prediction, you see that next to the generated word there is a temperature. So we can set the temperature as small as 0.2 to as big as 8. There is if you make the temperature very low, it will predict a specific word, but if you make the temperature high, it will predict other word as well. Similarly, there is a sampling as well. There is a top K sample versus top P sample, and we'll be understanding what are those, what how it works. So basically, for now, let me set a temperature 1, and let's me sample 14 and top 0.5, right? So and then I'm gonna click on generate again. The capital France is the France. So this is not the actual result. So let me. This is not the result I expected. So what I want is this is hallucination because the temperature is off. So let me minimize the temperature and let me rewrite this. My word is right, and then what I'm gonna go do is and then there is we can do the probability configuration as well, and then one moment. It predict Paris, and then if I just hit again to generate the next word after the capital of the France is Paris, then what come next? Let me click on generate here. Is generate predict the comma. Actually, I wanted to predict the full stop period, but it predicts this one. That's because the temperature set. So we can adjust the temperature a little lower, then it can predict the next word. So this is how it works. You can play around with this a little bit more if you like. But for now, let's go back and go a little bit more, do a little bit more on the other topics, understand a little bit more on the other topics, right? Next is Agentic AI. So we'll just see how LLM works in real time, how the predict the next word, basically prediction. Next is Agentic AI. Agentic AI is just like a robot, right? It's an agent. It contains LLM. It contains tool. It contains knowledge and memory. So it is basically the program, agentic program that can help our day-to-day life. So that is something called the agentic AI. That was about the basic. And let's move to next step is how it works. So in high level, how it works, we just quickly saw that that video or transformation transformer explainer to predict prediction, how the prediction works. But in high level, this is how generative AI works. The first thing, when we write a code or write a language or write a type of prompt or ask an equation, it will split those question into smaller piece of text. That because the whole word, LLM doesn't understand the whole word just like this. So if I write the capital of France right here, it just changed to DOS separately, capital separately, off separately, and things like that, right? And then it's changed to the embedding quorum just like that. In other website, if you wanna take a quick look, there is a tokenizer site, so where we can take a look. So if I type this, my name is Dilip, right? So let me write my name is DILIP Dilip, and then let's see how it's tokenized. So it's token 1, 2, 3, 4, 5, 6 pieces, six different pieces. So what it will do is it's gonna create the ID for those each token, and then this ID will convert it to embedding, and those embedding will go to vector database for the and then we'll be doing the semantic search. So that's how the flow works. But for now, the first step, once we give this kind of human readable language, it will convert to the token. So the token is just like that. So going back to here, I have added some example as well. When we give some word, it will generate the token, and we'll be covering why this token is important as a part of the limitation in next section. But quickly go over right here. So why token is important? Because most of the LLM or generative AI cannot handle everything on your mind. It has a limitation to handle the token. Like for example, for GPT-4, it can handle 128K token at a time. For GPT-5, it handle 4,400K tokens at a time. And things like that. So this has a limitation. It cannot do all your work as things. So that is something, the context window, which is the is a part of the limitation we'll be talking about. That's so token versus content window for limitation, right? The second step, how it works. We are going to quickly cover about this prompt engineering and context engineering. These are something we already familiar, most of us already familiar. Prompt is basically the question that we ask to GenAI. For example, hey, summarize this article, right? Explain this block, or what is the capital city of France, and things like that. That will be our prompt. And the GenAI will generate the predicted answer for us. That is prompt. And what is prompt engineering? Prompt engineering again is to write a better prompt. Computer AI response in better way. That's the prompt engineering actually is. And what is context engineering? Context engineering again, like I show you, every agent will have window, some specific window that can content specific or limited token, right? It cannot handle unlimited token. There has a limited form. So you can place maybe 4,000 word or 8,000 word, or like I said, the 8,000 token only. Some places, some window. So you have to be engineered how to write your content. You have to be better to write the content to get the better result. So that is what all about the content engineering is. So writing better content for to the better result. That's the content window. Okay. Coming back to the limitation again, context window is one limitation because it cannot handle unlimited text need that we have. The next is hallucination. Hallucination is something that when computer or AI doesn't know the answer, it will give the fake answer. When you train the LLM, when you build the LLM, if you do not train that specific thing, then it doesn't know it, right? Then if you do not train that specific question to LLM, it doesn't have those answer for them with them. Then what it does is it will give the fake answer with a confident. So basically, when AI confidently make false answer, that is something called hallucination. So we need to be careful, for the hallucination. AI will be, make us fool. AI fool himself as well, because he doesn't know, but he thinks that is right, but he actually giving us the wrong answer. That is something called the hallucination. Why hallucination happens again is insufficient training data. When training period, that specific question wasn't trained, then that hallucination happened. Also, the second most reason is incomplete or ambiguous prompt or context. If you provide ambiguous, incomplete prompt, then that will have a hallucination happen. That is the limitation of GenAI. Another limitation is temperature, right? What is temperature? Like I show you in earlier example, we can set the temperature. Based on that temperature, the result may vary. So you see, if I set the temperature low, it is generated here full stop, right? But if I move that temperature little higher, it start giving end, making something up, something else, like inverted comma and things like that. So temperature is another limitation we have to be careful about. So high temperature or low temperature is basically most accurate result, stable result. High temperature is a random result basically. So that's another limitation we need to know about GenAI. Okay. With that said, we are moving to the core concept of GenAI pipeline. We will be talking in this section. We will be talking about chunking, embedding, vector search, RAG, and agentic RAG. So most important terminology we need to understand. What is chunking, right? Let's start with the chunk. In simple, Chunking is like splitting large data into smaller pieces called chunking. Why we need chunking? For the better search and better accuracy. So again, LLM or AI or Gen AI cannot read everything all together. If you upload large set of file PDF file, it cannot read everything to answer our question. How it works is at the beginning of this pipeline, it will chunk our data in smaller pieces. So the first thing is chunking, is our first step for GenAI pipeline. It will chunk that data. So there is a multiple way it can chunk. One is sentence based chunk. Second is paragraph based chunk. Another is overlap chunk. Another is videos summarization based chunk, and many more. There's multiple way we can chunk it our source data in order to create the better pipeline, GenAI pipeline. That is chunking, the first step, chunking. The next is embedding, the very important concept, embedding. What embedding is? So embedding is, again, like computer doesn't understand or read human language. It has to convert all the human language into the numbers. So a computer, if you know the computer only understands 0 and 1, right? That's the theory. So it doesn't understand what is my language, what the language I speak. But the language I speak, that will convert it to the number and store in the database, so computer can process the language I speak. Again, embedding is turning text into the number for capture meaning. So the AI convert all the chunk into the long list number and save in the vector, and it's gonna save in similar meaning, for the similar meaning. It's not gonna be saved everywhere like on traditional way or random fashion. It's gonna save those number with the semantic result to get the semantic result. That is about embedding, very important concept. When we build a GenAI pipeline, we need to build this embedding as well. There is a function, we have to write the function to create the embedding using Python code. So I'm going to show you how we can build the embedding later when I do the demo video. The next is vector source. So vector source is basically another important mathematical concept. If you remember the math in your high school or college, there is a vector specifically you need to have to read, right? So vector search is basically find the similar meaning. Like in embedding, what will happen is converted word to the number and then is saved the data for the similar meaning and one like a set. Like set A, set B, and then union of set A and B, intersection of set A and B, and that way it's going to store. But vector search is basically finding the accurate result or a semantic result. When user asks a question, what will happen is that question will convert it into chunk, and chunk will convert it to embedding as a number, and then it will go to the vector for the vector search. Right, to find the semantic result, and that result, when we find that semantic result, that result will give to the user as an answer. So that is how generative AI pipeline works. The next step is RAG, understanding the RAG. RAG is basically what we discuss as of now. So basically, in GenAI, those are the process, right? To create the pipeline process, chunking, embedding, vector source. So those when we put those everything together, that is something called the RAG. Right. So that's the pipeline. RAG is pipeline to when user asks a question, and then from that point to get the result. Everything happen inside is a RAG. Retrieval augmented generation, right? So basically, in that pipeline, what will happen when we have the source file will convert to text to embedding, and then embedding as a numeric number will save to the vector database, and then user will ask the question, and that question will ask change to embedded as well, and search for semantic result. And that semantic result will give to the to user with the help of LLM. That will generate the better answer for them. Okay, that is about RAG. How about agentic RAG? So agentic RAG is again little next level of RAG. RAG is a traditional first phase, but agentic RAG is something called like upgraded version of RAG. What will happen in traditional RAG? It will just go search do the semantic search in vector database. But in agentic RAG, it will do the multi-step reasoning. Not just going and searching into the vector database, but also it will go and find the external tools, search in the external tools. It will retrieve more. It will iterate until find the confident. It will do little deep search basically before we give the answer. In regular LLM or regular RAG, there is a straightforward query, go to the vector DB and give the context, and then LLM will give the answer, right? The same thing happen in agentic RAG as well, but it will do in between. It will do the multi-step reasoning. And there is a if you heard about the LangChain, if you heard about the lambda index or semantic canal or many other modern tools, they use agentic RAG right now. So these are the framework that makes RAG application easily and more powerful, and it will give very confident answer nicely for us. So those about chunking, embedding, vector search, RAG, and agentic RAG. The last topics I want to cover is section 5 is Databricks role for enterprise. So in enterprise level, if somebody in your manager asks, let's say about, hey, we need to create the GenAI we have this file, and the user wants to ask the question from this file. So if your manager asks that question, what you need to do? You have to open your Databricks, right? And then you have to build your pipeline, GenAI pipeline in Databricks, and then you can deploy. You can build that pipeline and then deploy it, and then you can create the chatbot for the user. Then user can directly communicate with your internal data source. Why Databricks? Because Databricks is a single, secure, and scalable platform. Single, secure, and scalable platform for deployment, monitoring, and control. So again, GenAI pipeline will be easier with the help of Databricks. We can build generic GenAI pipeline with the help of Databricks again. And that is what I wanted to cover as the theoretical part and the first part. So we covered, in summary, what we have covered is at the beginning of this pipeline, GenAI pipeline, we will have a text as a source file, or source can be anything, PDF or pictures, or any internal file, or is a SQL database or anything like that. And those data will convert it to chunk, and we can add the metadata, and then after the chunk will convert it to embedding, which is number basically, and embed we can perform the semantic search using vector search for that embedding, and vector search will give the context, and the context will be nicely polished with the LLM and provide the answer. So that's how the pipeline, GenAI pipeline. As I said, this is my theoretical part as my the first section. The next, I'm gonna build a traditional pipeline using Databricks AI, and then after I'll be creating GenAI pipeline through the Databricks. Okay, let's start our second phase of this journey to do data pipeline to GenAI pipeline. In this phase, I'm gonna build the traditional data pipeline using Databricks AI. For that, let me go to my Databricks dashboard. So in this dashboard, what I'm going to do is I'm going to create a new catalog. So let me create a catalog. Click on catalog and click on plus. create a catalog. So I'm going to name is the traditional data pipeline catalog. Catalog is just like a database name, right? I'm not going to configure anything, just ages. So within this catalog, I have a default information schema. There, I'm going to create a new schema called I'm going to order ETL schema. So I'm going to create order schema, and then the path will be, let me just create there. So order schema was created. So my catalog is ready, schema is ready. So in this database schema, I will be creating the pipeline. So my pipeline is basically will be getting the source file, and then I will be building all those tables. Like we will be utilizing a medallion architecture. When we say the medallion architecture, it will be bronze layer, silver layer, and gold layer. So in bronze layer, we'll be bringing file AZs as for the history perspective, and per silver level, we'll be cleansing some data, remove duplicate and things like that. And for gold level, we'll be preparing a final data set for AI ready or business ready data. So that all pipeline, it will be created with the help of Databricks AI. So that is, I'm going to show you how that's going to happen. So for now, I'm going to quickly show you my source file. And my source file is right here in download folder. I'm going to use JSON file as my source file. If I open this as a notepad, for now, just quickly show you how this file look like. JSON, or this is a order test data in JSON format. So I'm gonna add this source to my Databricks. In order to do that, let me go to this schema, and then create. I'm gonna use create the volume. So basically, what I'm doing here is creating a volume, basically updating that file. So I'm going to name that volume, source file volume as order underscore JSON. It will be manage volume, basically manage volume, external volume. I'm going to use manage volume is already automatically choose our appropriate catalog and schema here. So I just need to click on create. So a source file was created basically right here. We can use this source file using data ingestion tab, and then upload the volume from here as well. It's the same thing, and as well as we can have the source file in variety of connector like Amazon S3, Google Analytics, SQL Server, ServiceNow, etc. Right? So, but for now, since we had a file, we upload as a volume, and our source file was within our schema under this catalog. There is a file. Let's see. This is the file that let me quickly save this location, and then I will need this later on, right? Okay. Save that on my notepad. And what I'm going to do, the next is I will be creating the pipeline. So in order to create the pipeline, just hit this pipeline, and then pipeline, and I just need to click on ETL pipeline because we are creating the ETL pipeline. The reason for this video is to demo create the pipeline using AI, Databricks AI. So Databricks is using GenAI AI. So I'm not gonna code anything to create the pipeline, but I will be writing a prompt to create the end-to-end pipeline. So when I click this Jenny, it start writing a prompt. So let me make a little bit bigger of this window so we can view it quickly. This says the setup of the pipeline. I can write manually right here. What I can say is, hey, my source file is there. I need to create a pipeline to upload the source file into that newly created catalog and that schema. And I wanted to cleanse that, and things like that. But I already wrote that on my document. So I'm going to copy these and paste in there. So right here, what I'm saying here is create the full medallion architecture pipeline using autoloader. So basically, I'm asking to create the medallion architecture pipeline, where I said the source file is right here, JSON file, the source is there. What they need to do is, this is basically the content for creation. The bronze, it need to be like that. For silver, they need to cleanse the data, cast the type, remove the duplicate, and do those, right? And then for the gold layer, what you need to do is we need to create the two business metrics. One is city-wise total sales which is aggregated data, and also again total order group by order status. So this is what my goal should look like, right? And then I have created this prompt. So what I'm going to do, I'm going to paste that prompt right here. And there is two options, chat and agent. Make sure you need to select the agent. So agent will do all of our work into it. As soon as I hit this tab, it start working and it start creating medallion architecture for us. So for now, I just need to sit back and watch it. If this found any issue, any error, it automatically detect that those things, try to fix things. Once the pipeline was ready and create, what is going to happen is it's going to ask to do the test run or try dry run. We can do this dry run. This doesn't actual run, but it basically testing those pipeline, and once we feel like everything looks good, then okay. So one thing I have noticed is I need to change this catalog from workspace to my catalog, and then this one right here. So it's going to detect that error, and probably it's gonna ask me to change this afterwards. Once it asks, I'm gonna update that pipeline right here. Okay, within a minute, so it's just complete its work. What happened was it created, bronze level, silver level, and a gold layer. All the file is needed. Now is asking to do the dry pipeline. So before I run this dry pipeline, make allow. Let me quickly go to and see how the pipeline it looks like. It looks like it's created bronze, silver, and gold as expected, as we noted. So if I go to the pipeline again here, and then let me click on and within a matter of minute, my pipeline is ready. I can view that pipeline by going data pipeline. Click on this pipeline right here, and then if I expand this one and then view a little closer, maybe just like that. So bronze table was created, and inserted 1,000 rows record. Silver table was created, and is cleansed data and inserted 772 record, and then for gold table is expected is created 2 table. So this is how Databricks, we can create the pipeline using Databricks AI. That is what I wanted to share quickly in this part of video. This is basically the traditional data pipeline. I just want to show you how we can utilize Databricks AI to generate this pipeline. So that's all for this. Next, we'll be moving to next step, our actual step called walking through the GenAI pipeline creation. So let's jump into that. All right, let's build the generative AI pipeline using Databricks. So in order to build into generative pipeline, there are some of the steps we need to perform, and required some time to write this code. In order to save that some time, I already wrote the code in Databricks notebook. I'm going to walk you through everything from start to bottom with you guys. So for that, in high level, what we are going to do as a part of this session is we will be storing source file on Databricks, or you can store or connect your source anywhere on your location, and that can be anything. For me, let me quickly show you. If I go here on my download folder, I'm going to use these two documents. I have the travel and expense policy document and refund and return policy document. There is two documents. Is straightforward document. These are going to be utilized for my demo. Those are my source. So I'm going to upload those file, those two PDF document on Databricks, and then next step is we'll be converting those source file into text, because those PDF cannot be read by LLM or GenAI. So it has to be converted to text. And then what you need to do, we need to change to the chunk. right? Smaller chunk, like we discussed earlier. And then in order to make sourceable, faster result, we have to add metadata. It's optional, but it's nice to have. I'm going to show you how to add the metadata. And then once that converted to text and chunk, and then the most important thing is we have to generate the embedding for those. Then embed will be saved on vector database, and then after we will be performing semantic search for every user question. Once we perform the semantic search, this LLM or basically AI, generative AI will or this process will give the top matching semantic chunk for us. Up to this step, we are almost finished, almost done about creating pipeline. And the second step, we'll be adding the LLM for the final and better user-ready answer. So I'll be doing everything end to end. So let's begin with loading a source file. For that, what I'm gonna do is I'm gonna go to data ingestion here. And then I'm gonna upload my file. Actually, I already uploaded this file. No, I think PDF file. Okay, I think I already uploaded this file right here. Yeah, refund policy, return and refund policy, right? So what I'm gonna do is I'm gonna go there and get this file path. Let me go and get this path. And here is the file path, and I have copied over to my text. So I'm gonna these are my source file of refund and return policy and travel and expense, and they are uploaded on workspace default policy file location, right? So these are location. Now I'm gonna go back to my notebook again and open that notebook. Demo, let me see which notebook that was. Yeah, GenAI and demo 2 notebook, right? So next step is what we need to do is, since we have the PDF file and source, we need to create the generative AI using the PDF file. We need to create some PDF reader. So for that, I am gonna install PDF2 right here. It should be completed. So that was just completed install by PDF2. Why we are doing that? Because we wanted to use that. So we are importing that and creating a function called the read PDF. And what we are going to do is we are going to read those files. So there is the file. So I'm gonna replace my path. Let me see. There's my existing volume, and this is my updated path. So let me update this correct path. So right here, this is the function to read this file, and these are the file, and it's going to read as a text, and then return 500 character, right? Or 500 for both of these files. So let me quickly run it. And then is return as expected 500 result. However, this text was written from that PDF. Next step is we have to chunk those data. So if I expand these, this is the another first step we have to perform is like chunking, right? Like we explained earlier. So let's do that. What we are going to do here is we are going to create the chunk text function, and again we'll be chunking those on those texts, and then let's quickly see how many chunk we're going to return here, and then also let's see those chunk how it looks like right here, right? So if I run that, it looks like the chunk is created 7 chunk from the refund and 7 chunk from the travel, and these are the sample 2 chunk. This is how the chunk was created from that file. And then let's do the next step. The next step is basically, since we are utilizing Databricks, what we are going to do is we are going to create the data frame. So when you say the data frame, basically, is we are creating the table for those chunk and save them as a table, basically, right? So create the data frame from those refund chunk and travel chunk. and then display at least one refund chunk. Let's quickly take a look how it looks like. Now, it's created a chunk ID, and then it's loaded is this format. However, I've seen some issue here. It's chunking and saving is not very really good format. If you see these, this is not like a sentence. If you remember, like last time when we talk about the chunking, right? The chunking can be sentence-based chunk, paragraph-based chunk, overlap chunk. But when you see here, this is not look like the sentence-based or paragraph-based or anything like that. It's a random chunk, right? So for that, what we're gonna do is I'm gonna split the chunk by the bullet. So I'm going to split by the full stop or bullet, and it's going to be run as a paragraph chunk. So this is a little bit same. We are going to update the chunk text function and display it by dot or slashes, right? And then again we'll do the same thing. Include that, run that function against the data frame, and then display the result. So let me quickly run it and see. Okay, this is much better. Now is chunking based on the column, right? Like sentence-based chunking. Why we are doing this is, it will be, result better at the end. It will when you do the semantic sorts, then it will send back better result, semantic result as a sentence. So because of that, we have done that. We can do more, but for now, this is looks good for me. Now, what we are going to do, next step is adding a metadata. So at the beginning, what I have told you was, after the chunk, we can add the metadata, right? So before we do the embedding. So that step I'm going to perform here is the adding the metadata. We can do many things. More metadata will helpful for performance, for better semantic sorts. For now, what I'm gonna do is, since we have a two file, a refund policy and travel policy file, I'm gonna add a column for those two file as a source column, and then define as a separate as a refund policy or travel policy. So quickly run that, and then what it's going to do here is edit the source and then define where this is coming from. It's all coming from the refund policy. And if I wanna refund, and it should display all the data. But for now, I'm good with that as well. Let's move to the next step. Next step is the most important step is adding a meta. Okay, I think we have done this metadata, right? Okay, so right here. What we have done was basically we created added two column to distinguish these two. So display return DF and travel DF. First line is return DF, and second tab is return travel DF. Travel policy. That's good. Now, I wanted to create the table. I wanted to save those record in my Delta table in Databricks. So for that, I will be adding, let me quickly run this. So, and then I'm going to explain what is happening here. Okay, there is some error, and it's try to fix automatically. And then I know what is going on here. Override delta, Zeni. So what is try to say is there is something error on this, and it try to create the generate the script. Hey, create if exist. Create using skills. Let me actually this schema does not exist there. So let me do if that's gonna help. Let me save that. Create if exist and then run it, right? So let's run it. Yeah, it failed again. Let me try to rerun again. Let's see how powerful this Databricks fix it. It sounds like it's still struggling to invalid syntax. So what I'm going to do instead of doing that, I'm going to go back to my original syntax, and then I'm going to change my catalog myself. So if I go to the new tab for catalog, I will be putting those data, this file right here, right? Policy file, PDF file in this workspace catalog. So I'm going to change that. Instead of GenAI, I'm going to change that workspace and default. If I change that, I should be able to run it. Invalid. Workspace is invalid. Okay, now it was done. So basically, we are combining this refund DF union with the travel DF, and then display that combined result. So this is where it's displaying combined result. And also we are creating the table on this directory as policy chunk table. So if I go back and take a look, we should be able to see the policy chunk table. So if I extract down, there is a policy chunk table is created, and then I can view the data. In order to view the data, I have to run the server, and data should be available here, the updated data. This is a delta table created as of now, right? Moving forward, or optionally, I can verify those data from here as well. So let's start from the not the Genie, but the workspace default. Workspace, and then run it. I should be able to see top 20 record, which is good. The next step is the critical step is generating the embedding. So we are the next step for creating the embedding after this chunk and many other steps, right? So next step is embedding. For embedding, there are multiple steps we have to perform to complete the embedding. Embedding is basically, if you remember that our discussion, we are converting because LLM or GenAI doesn't understand the actual human language. It's converted to numbers. So why we are converting a number is because for the semantic search or vector similarity or RAG retrieval, faster retrieval, right? So that's embedding is important. So in order to complete the embedding part, there is a couple of steps we have to perform. First step is to set up an embedding API, and then next step we have to create the function. Then we have to implement and those embed on our data. So let's do that. The first we'll be importing API. Embedding API, and then also we'll be creating the function. This is how we are going to create the embedding. So that is completed, and just to verify, if that function we created the get embedding function. And just to make sure if get embedding function works or not, right? So I'm putting some text right here. Let me change this and then run it. So right now this this function works, is creating some embedding text like a computer. So if I change that text to something else and then rerun again, these numbers should be changed. Yeah, these have changed. So function is working. So I'm going to implement this function on against our data. So embedding function will be implemented to our DF, right? So I'm going to run that to our text. So I'm going to run that. And then it's going to be display at least 10 result from the test result. So 10 result was displayed, and a chunk ID there, text is there. If I scroll left, source is there, and then the embed column was created. So embedding was done nicely. So this embedding is data. If you want to know more about this, we need to understand machine learning. These are all math, right? Vector, things like that. So this is how the computer understand the text. So it will be saved on vector database, and when you ask any question from the user, it will go to that database and do the semantic search, similarity search, and bring that embedding number again, and then display the corresponding text to the user. That's how it's going to work, right? So embedding was done. Next step is the optional. We can create to embed to the pandas. So let me quickly run that apply that embed function into pandas. Should be completed as well. Yeah, that is completed. Next step is we are almost done. We are all set for semantic search now, right? So if I go back here, semantic search or vector search. So we have done chunking and embedding. We are doing this is all the RAG. We are doing the RAG thing, right? So chunking, embedding, vector search is about the RAG. So we are building that RAG pipeline right now. So we have done first two. Now we are doing the vector search. So vector search is nothing but a user query. So our text, our PDF, these two PDF, what we have done again, like if I go back to my source data, these two source data was chunked and embed and save them to the database. Now, any question user asks, like, what is the meal allowances, right? It's going reading from the pandas that where our data was saved there, and then when user asks this type of question, what will happen is this question will embed as well automatically, and it will go through for the similarity search. And then once you found a similar result, then it's going to display to the user. So if I ask this question, user asks this question, what is the meal allowances? Again, it's going to embed again. This question was embed, and then go to for the similarity search, and then display the result, like this kind of result, whatever is found on that data. This was happened there. So let me quickly do another updated version of semantic search right here. I'm going to show you a couple of questions here for you guys. So it will be searching against the pandas where our data set was there, existing data set, and then any question user will ask, like, what does the travel policy say about the meal allowances, right? And then we'll expect some answer. And this code, the question will be again embedded, and it's going to be the similarity search, and then and then there is a threshold, something called the threshold, right? This is another important thing we need to we will know about, right? And then if there is no data, similar data is there, what I want to do is I want to return no relevant information as found on those documents. That kind of information I wanted to display. So those are code written here. So I'm going to run this code. Let me run this. So my first question is, what does the policy say about the meal allowances and the reimbursement? So if I run this right here, it's running it, and let me see if this is going to find the right answer for us. Sometimes there is some error going here. Let me quickly fix that error, and I'll come back with you. Quickly, let's see. After making the chunk update and then run everything over my result, I just run this one, perform the semantic search, and then ask this question, what does the travel policy say about the meal allowances and reimbursement? So I asked that question, and I got the result like this is what I expect, right? So this was my question, and my GenAI give me this result based on the file I provide. If I ask another question, like if I comment that question out and then ask another question, like how many days allowances for return, and then run it, let's see what kind of result is gonna give for me, right? It's performing right now. And then you see how many days are allowed for returns. It says the correct answer, like 30 days return window for customer to return this. Okay, this is what we are expecting to get the answer. So I quickly show one more thing, like if I ask the outside of box question, something like let's say let me ask, who is the president of United States, right? So this is something the general question that GenAI can answer it. However, since we are building our own, it's not gonna give that answer. This because that particular answer is not relevant to our within our document. So this answer is no relevant answer found on policy documents, like document that we have. If you ask another question like that, all right, what is stock market is doing, like that, and things like that, is going to see the same thing. Hey, we are not getting that information on that document. No relevant answer, document was found. That is what these answer was generated, or not the generated basically is this point is getting the chunk from that document, right? And I want to show you something another interesting. So if I ask this question, another question, what is the meal allowances daily limit, right? So I'm going to show you how this is going to react. So as I said, is this point, once we have this question, basically this question will be embedding, and then it's going to be searching those embed in with a vector database, and then find the similar chunk within that vector database, right? And then display that chunk. And you see, I asked that what is the meal allowance daily limit? It answered that it just found this chunk on that document. Meal allowance daily meal limit, and then the stuff here, because on that particular document, it's not written formally like to answer this question. That is why this is going to happen in many places, or many other question that user may ask, right? So in that case, what we need to do is we need to add the LLM on top of it. So LLM will do rest of the job to make answer better for the user. So the next step is we are going to add the LLM. So again, to summary, at this point, what we are doing, we have doing up to this point, like highlighted point. So we add a source, we convert the source to text, then we made a chunk, we add metadata, we did generate embedding, and that embedding data stored in vector database. We perform semantic sorts, and semantic sorts give us the most relevant chunk to us. Now we are going to add the LLM on top of it and get the final answer. So in order to get the LLM, there's a couple of things that we need to do basically. So as of now, we are just getting a chunk from our source document. Now this part is already completed. Let me close. So to make answer better, again, like we have to add the LLM to get the final best answer, because like I show you some of the answer is not relevant or not fully answer to the user without getting adding LLM. So in order to add the LLM, so what you need to do is we need to call the LLM library. Like there is a multiple thing. Maybe we can do OpenAI. We can do some open source library as well, based on the thing. For now, I'm using installing OpenAI, and then I'm restarting the Python, and then basically having this LLM, installing LLM on my work. Okay, so this was download completed. Next is what I need to do is now installation completed. Now I need to add my key, to add my API key to this LLM. So this is a generated API key. So this API was generated. I'm gonna revoke or delete afterwards. I'm gonna regenerate afterwards. But for now, what you need to do is, if you want to use the OpenAI API key, you just need to go to the platform.openai.com/API keys, and then you need to generate the new key, and then you can use that key on your work, right? That way. So I'm going to use this key for now. I'm not sure. Okay, and then after what I need to do is I can ask this kind of answer those questions again. However, like in my case, this is the testing LLM. Let me see if that's gonna reply. No, for now, this LLM is not returning anything because the insufficient code, or my LLM doesn't have a sufficient font, because this is just demo purposes. When I open this OpenAI, I do not have any credit. In order to have the credit, I need to add my credit card and have some fonts. So my once I have those fonts, then API key start working. So since OpenAI LLM is paid version. So for now, I do not have the paid version. So my LLM key does not work for the final result. However, if you really wants to test this out, this is all you need to do. So basically, you need to install this LLM libraries and then call your API keys for that LLM, and then you can run the same create the chatbot basically, right? So your chatbot will start acting as a purified generative AI based on the source file you provided. So that is how it works. This is all I want to share in this video. So in this video, basically, I have shown you share with you all of this step by step, and this is all the step we need to know in order to create the pipeline. So since I have this all these steps, what you need to do, you need to save this step, and then maybe schedule this thing in daily, monthly, or uh, or weekly, anything that we need based on our need. All right, so this is about a demo of generative AI within Databricks. Thanks for watching. Bye for now.